Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill.
Hello everyone, we are GSIs working at the University of Michigan on our graduate level thesis paper.
We are researching how much the general public knows about Lewis dot structures.
We're going to ask people what they know about Lewis dot structures and see what their response is.
After that, we'll give a lesson on how you draw these structures.
No.
Is
Okay.
it science?
Yeah. Chemistry.
I don't know anything.
None? Alright,
We're at a
thank you.
loss. Sorry.
Thank you.
Lewis dot structure?
Yeah. Think back. All the way back.
Oh, I know this kid knows over here.
You know what a Lewis dot structure is? No, I don't know.
You don't know what?
No.
Oh my.
I know what a Lewis dot structure
Alright,
is.
okay.
I draw those in my sleep.
Okay. You guys are the first ones to know, so yeah.
Is that the question?
Yeah.
Oh.
Okay, you want to explain
Explain
it? Yeah.
Okay. Count the number of valence electrons. Subtract the number of electrons that are bonded. Fill that crap in. Draw some double bonds. Done.
First, we're going to talk about what a Lewis structure is. Again, Lewis structure is a formula to represent molecules. So when you're looking at a Lewis structure, the bonds are represented by lines, and the electron pairs are represented by dots. We have a hydrogen atom and a chlorine atom. Hydrogen, from looking at the periodic table, has 1 valence electron, and chlorine will have 7 valence electrons. And when these come together, they will share 2 electrons, as you can see from this region right here, forming a covalent bond. As you can see, if you bring this down here, a line will represent this. When one pair is shared, it's called a single bond, represented by 1 line. So you have your bonding pair, and then you have 3 pairs of lone pairs around the chlorine. That's how you draw a basic Lewis structure.
Now we're going to talk about the steps for drawing a Lewis dot structure. First step is to calculate the number of valence electrons in the molecule. Next, you want to write the skeletal structure, making sure to put the least electronegative element in the center. And lastly, you want to distribute the electrons, making sure to satisfy the octet rule for all elements. The example we're going to be doing is BF4-.
Okay, so now we're going to calculate the valence of electrons. First, you add the valence electrons of each element present. Second, you add the electrons if the charge is negative, or subtract the electrons if the charge is positive. So, boron has 3 valence electrons, fluorine has 7. So, 1 boron times 3 electrons plus 4 fluorine plus 7 electrons equals 31 electrons. Then you have to add the negative charge. So you have 31 electrons plus 1 electron equals 32 electrons.
Okay, so now we're going to draw the basic skeletal structure for BF4-. First step is to place the least electronegative element in the center. Electronegativity measures the tendency of an atom to attract electrons. Always remember to put the least electronegative element in the center of your Lewis dot structure. Then you're going to want to connect atoms with single bonds. So you're just going to have a basic structure with single bonds.
No. You have no idea?
This is from chemistry. I vaguely remember it from senior year of high school. I don't really know what it is.
Can you give us any details at all?
No.
Oh, that's how. Is that the rule of bass and guitar?
Chemistry.
I'm technical. I don't know. I'm applying to Ross.
Okay.
I don't need science.
I do know what the octet rule is.
Do you want to explain it for us?
The octet rule just means that all electrons, when bonded to other electrons, want to have 8 electrons. So in other words, they're more stable.
Okay, so now that we've built the structure, we're going to look to distribute the electrons next. First thing you need to know is the octet rule. Atoms look for 8 valence electrons surrounding them. That will fulfill the octet rule. The notable exceptions to this rule are helium and hydrogen, which just look for 2 electrons. And then the next thing you're going to do is distribute electrons to the surrounding atoms of your molecule first, and then after that, any remaining electrons will go around the central atom. Okay, so looking at our structure, you'll remember that we counted up 32 electrons for this molecule. And if you see, we've already put in 2, 4, 6, 8 of them for the single bonds. So the first thing we need to do is fill up the outer atoms. So we're going to add 6 electrons to each of the fluorines to complete their octet rule. So, you gotta see, I'm gonna put 6 on each fluorine. So now that each fluorine has satisfied its octet rule, if you count up all of these and the bonding pairs, you'll get 32 electrons. That means all the electrons have been used up, so boron doesn't need any of the extra remaining electrons. And also, if you look at boron, you'll see that it has 8 surrounding electrons, so it also completes the octet rule here. You'll remember that this molecule did have a negative charge, and if you do have a negative or positive charge, you do need to add that in at the end, so we'll do that right now. And there's your Lewis structure.
So now we're going to do an example that involves multiple bonds. The first step is to calculate the total number of valence electrons, which for carbonate is 24. Then you're going to draw the basic structure, which is just single bonds between carbon and oxygen, and distribute the remaining 18 electrons to the outer 3 oxygens. But if you look at the central carbon atom, there's only 6 electrons surrounding it, which does not obey the octet rule. So we have to put 2 of these valence electrons in the form of a double bond, which gives the carbon 8 valence electrons.
There are a few exceptions to the octet rule. Hydrogen and helium have less than 8 valence electrons in their shell because they only have 1 s shell to fill. An example of this is the H2 molecule, which only has 2 electrons. Another exception is for elements in period 3 and below, which can have more than 8 electrons because they have an unfilled d shell. An example of this is xenon in this molecule, which has 12 valence electrons instead of just 8.
Something about, I don't know. It's something about orbital.
You do not know anything. All right. Thank you very much.
Yeah.
Related to chemistry?
Yeah. No idea.
No, what is it?
That's for you to find out in our video. I don't know.
Sometimes, when you're drawing Lewis structures, there can be more than one arrangement of bonds and electrons.
Take for example O3. As you can see, there's a double bond here, and now the double bond has moved to this oxygen.
Well, everyone, I hope you enjoyed our lesson today on Lewis structures.
This concludes our presentation.
Thank you.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
SSG is awesome.
Yeah. All right, we're good.
Bill Nye the Science Guy.